Max Planck was born on April 23, 1858. His mother was Emma Patzig, and his father, Johann Julius Wilhelm Planck, was a professor of civil law at the University of Kiel. In 1867, he enrolled in the Munich Cornelicus Maximilian Gymnasium, where under the guidance of Hermann Müller, he learned about astronomy, mathematics, and the conservation of energy. In 1874, he enrolled in the University of Munich, putting his full concentration into mathematics as his interest in physics grew. Despite falling sick during his first year, he fully recovered and by 1877 continued his studies in theoretical physics at the University of Berlin. In 1879, he graduated with the highest distinction, focusing his work on the second law of thermodynamics. After a brief period teaching at his former secondary school, Planck was appointed as a professor at the University of Berlin in 1889, taking over after the passing of Kirchhoff. He remained in his position until his retirement in 1926. By the end of the 19th century, physicists were struggling with a major problem, explaining blackbody radiation. Blackbody is an idealized object that absorbs all electromagnetic radiation it comes into contact with and then emits thermal radiation in a continuous spectrum according to its temperature. However, classical physics cannot accurately predict the energy distribution of this emitted radiation. This failure became known as the ultraviolet catastrophe. While Rayleigh's equation worked at low frequencies, it failed at high frequencies. Conversely, Wien's equation worked well at high frequencies but failed as well. Classical physics falsely predicted that there will be infinite energy at high frequencies. This is where Planck changed everything. In classical physics, energy was thought to be continuous and able to be divided into arbitrarily small amounts. Planck's theory challenged this by proposing that energy is not emitted continuously. Instead, it is emitted in small, discrete, and indivisible packets called quanta. He formulated this with the famous equation E equals to h nu. In this equation, E represents the energy of each quantum, h is Planck's constant, and nu represents the frequency.
Now, I will continue with the impact of Planck quantum theory on science and society during his era. Before Planck, physicists believed energy was smooth and continuous, but Planck showed that energy is actually quantized, released in small packet called quanta. This one idea completely reshaped physics. Einstein used it to explain the photoelectric effect, and that's what earned him the Nobel Prize. Bohr used it to build his atomic model, where electron jumps between fixed energy levels. And later, Hansberg and Schrödinger built the entire mathematical framework of quantum mechanics on Planck foundation. Fun fact, Planck himself didn't fully believe in quanta at first. He called it as desperate act, but it turned out to be the most successful guess in physics history. Now, what about society? Before quantum theories, people believed that universe was like a clock, completely predictable. Planck's work, along with others, introduced probability and uncertainty at a smaller scale. That changed how people thought about reality itself. But Planck was also an ethical leader. During the Nazi era, as president of the Kaiser Wilhelm Society, he quietly tried to protect Jewish scientists. He even confronted Hitler personally, which took a lot of courage. So, he remembered not just as a scientist, but as a man of integrity. Finally, why does this matter today? Planck's quantum idea is everywhere. In science, spectroscopy, quantum chemistry, material science, and astrophysics all depend on it. In technology, lasers, LEDs, solar cells, MRI scanner, and even quantum computers all rely on energy quantization. One quick example, MRI works by using the quantum property of atomic nuclei, specifically how protons in our body absorb and release energy when exposed to magnetic fields. This is a direct application of quantum energy transition, exactly what Planck's theory described. In conclusion, Planck's main contribution to quantum chemistry was introducing energy quantization, E equal to hv, proving that energy comes in discrete packet, not continuous wave. Second, during his era, disrupted classical physics, influenced Einstein and Bohr, then changed society belief from a predictable universe to one based on probability and uncertainty. Last but not least, his legacy today powers modern technology from laser, LEDs, solar cells to MR scanners and quantum computers. Basically everything in our digital world.